Welcome to an introduction to a very interesting topic in chemistry called nomenclature. My name is Memphis and this is nomenclature. First, we're going to start off with the standard system, which is the system of naming a group 1 or group 2 metal to a nonmetal. These groups are called the alkali metals and the alkaline earth metals. They will all have the same charge and will only be a +1 or +2 charge on each metal. Here is an example of how the system works. The standard system is formatted based on the metals and nonmetals charge. Groups 5, 6, and 7 will also work under this system. We will use sodium fluoride. This is NaF, or sodium fluoride. We need to locate where each element is on the periodic table to find the charge. We find sodium with a +1 charge and a fluoride with a -1 charge. Using a method known as crisscross, we eliminate all the numbers and end up with NaF. Pretty simple. Next, let's learn about the stock system, which is the naming of a transition metal to a nonmetal bond. This is a very unpredictable bond due to the amount of charges seen in the transition metals, going from groups 3 to 10 as seen below. Let's use sodium bicarbonate as our example. This is NaHCO3, also known as baking soda. Bicarbonate is hydrogen tricarbonate, hence the 3 after the CO. This is easily broken down to figure out, and you just gotta break down bicarbonate, which is the 2, and then you put in sodium in front. The prefix system is next and probably the easiest to figure out. This is naming a nonmetal to a nonmetal to bond them. You will see one of the 10 Greek prefixes when you are using the prefix system, which are mono, di, tri, tetra, penta, hexa, hepta, octo, nona, and deca. Let's use dihydrogen monoxide for example. The di signals that there is 2 hydrogen and the mono signals that there is 1 oxygen. This is H2O, better known as water. So the di means 2, so that goes to the 2 hydrogens, and 1 mono is the 1. When there is 1 for the first element, though, there's nothing. The purpose of nomenclature is to shorten down formulas to make it easy for the chemist to put together. The first modern system of this was published by a French chemist whose name was Louis Bernard Moreau in the year 1782. He wanted to help the intelligence and relieve the memory by shortening these compounds down. This made it easy. The, the Stock system was developed by a German chemist named Alfred Stock. It is used for inorganic compounds and often seen with Roman numerals in parentheses. It's used for nonmetals. There are 2 types of ions, the monatomic, which is a singular ion with a positive or negative charge, and the polyatomic, which is a group of ions with a positive or negative charge. To recap the systems, the standard system names a group 1 or group 2 metal to a nonmetal, the alkali or earth metals. The stock system names a transition metal to a nonmetal, and the prefix system names a nonmetal to a nonmetal to bond each other. The 2 formulas seen are the empirical formula and the molecular formula, which are the smallest whole number formula and the ratio of atoms, respectively. The 3 bonds are the covalent bond, a bond between the 2 nonmetals with the same electron, the ionic bond, a bond between a metal and a nonmetal to even out electrons, gaining or losing one, the metallic bond, which is the bond between positive ions and electrons. There are 7 diatomic elements, which are elements that bond with themselves: H2, N2, O2, F2, Cl2, Br2, and I2. In conclusion, nomenclature is good for chemistry as it names elements to another element to bond each other. It creates an easier way of looking at bonds and it is shortened too. Thank you for listening.